In this video, we're going to discuss the 5 different types of isomers that we find in organic chemistry. And then later, in following videos, we'll talk about each one individually. But this one's just going to give an overview of the 5 types of isomers.
Isomers are 2 or more compounds that have the same formula, but are arranged differently. They cannot be rotated to be the same compound. The bonds have to break in order to become the same compound. In this example, we have 3 compounds. 2 of them are the same compound, but drawn differently, but they can be rotated to be the same compound. One of them is an isomer of the other 2. So 2 are the same, 1 is an isomer. See if you can figure out which 2 are the same compound. Pause the video for a moment while you decide, and then we'll go on. One quick way to check is to try to rotate the whole molecule. So let's take A and flip it upside down and over. We're going to rotate it around, and we'll see that it matches with B, but it does not match with C. Another thing that you could do is to check for the name. So let's go ahead and try naming A. A is 1, 2, 3, 4, 5. It's a pentane. It's got a methyl group hanging off. So this is a methyl pentane. And we see that that is on carbon number 2. Notice that I'm counting backwards here. And then if we go to B, we see this is also 2-methyl pentane. So we can see our 5, and then here's our branch, and that's on carbon number 2. What happens with letter C? It's also a pentane. It's also a methyl pentane, but the carbon is now on number 3. So this is 3-methyl pentane, and it is an isomer of the other 2, which are both 2-methyl pentane. And A and B are the same. A and C are isomers of each other. When we look at isomers, there are 2 major types of isomers, and those types are structural isomers and stereochemical isomers. Now, structural isomers have them actually bonded to different carbons, or something is bonded in a completely different way. The stereochemical one is a little bit trickier. Those ones are held in space in a slightly different way. We'll come back to that when we get to that section. Of the structural isomers, there are 3 variants of structural isomers, and these are what we're going to categorize our different isomers into. The first category is skeletal isomers. Skeletal isomers talk about the carbon skeleton changing from one position to another. So it has the same number of carbons, but they are attached differently. In this class, we're only going to be talking about the alkanes having this type of isomerism. So there may be other types that could have it, but for this class, we're going to say only the alkanes can do this type of isomerism. Again, the carbon will be attached to each other differently. So there might be, in one case, there might be 3 branches, and another one there might be 4 branches. In one case, the chain length might be 3, in another case, it might be 5 carbons long, and have some of them as branches instead of as main chain. The second category of structural isomer is called positional isomer. Positional isomers start with everything basically the same, but the position of something that's attached is different. Now, these attachments are what we would call functional groups. So we might see the chlorine's on carbon number 1, and now it's on number 2. An alcohol that was on number 3 is now on number 4. They're moving their position. Really, the major thing is that the number changes on these, where the isomer becomes a different isomer because we moved it over 1 carbon. There are 2 instances where it's not just the number, the actual whole name will change because of the type of structure they have. And our third category of structural isomer is the functional isomer. A functional isomer is one that has, again, everything's basically the same, but we're changing the functional group. So it goes from being an alcohol to being an ether, or a carboxylic acid becomes an ester. Completely different class of compound. You'll notice it in the name, that the name will completely change because it's a new class of compound. And again, this can be for anything that has a functional group. Within the category of stereoisomers, we have 2 types. One's called the geometric isomer, and the other is called the optical isomer. The geometric isomers are the ones that have a double bond in them. They must have a double bond present, and they can either be cis or trans. We'll talk more about that later. The double bond has to be in the same position as it originally was, but we're going to have two things either facing up or down. Remember, in the stereochemical ones, these are held in a certain way, and they can't rotate out of that position. And the last category of isomerism is the optical isomer. Again, this is a stereochemical designation, but it is called an optical isomer. Optical isomers are probably the hardest ones to identify, but they are very, very common in nature, so they're not unusual, they're just harder to identify.
A simple example of optical isomerism in nature are your hands and your feet. When you look at your hands, you should be able to immediately tell if it's a right hand or a left hand, even if it's not attached to the body. Similarly, if you put your shoe on the wrong foot, you can tell because your feet are left foot and right foot, and they are different from each other. And for the most part, we would just say, oh, that's a foot. But when we're very specific, we can see, hey, that's a left foot and that's a right foot, or a left hand and a right hand. And that's how optical isomerism works. They look exactly the same, but one goes one way and the other one is held in a slightly different way and points the other direction. These will be the 5 categories of organic isomers that you'll be classifying different groups of compounds into. In multiple choice questions, you may also see the option of not isomers, which means they don't have the same formula, so it might have extra carbons or hydrogens or oxygens or whatever, or we might get the option of the same compound, where the two compounds are exactly the same, just rotated in space. In the following videos, I'll discuss each of the 5 classes of isomers in more detail. So to summarize, isomers are substances that have the same molecular formula but are in some way different from each other. For structural isomers, we see that difference is in the way that the atoms are bonded to each other. They're bonded to different atoms. In stereochemical isomers, they are only held in a specific orientation in a different way. These ones cannot rotate, and so they cannot be changed. The 3 types of structural isomers are skeletal, positional, and functional. Skeletal isomers talk about a carbon skeleton that is changed. Positional isomers talk about some kind of functional group being in a different position than it normally was. And functional isomers are ones that have a new functional group present. Same elements, just a different functional group. For the stereochemical isomers, we have geometric isomers. Those are the ones that have a double bond that cannot rotate, and so they can only be cis or trans. And then the optical isomers, again, are the challenging ones that have 4 different things attached in space in a different way.